Assalamu alaikum. This is the first class of volume of revolution. Okay, we have learned that in order to get the area bounded by the curve and the x-axis, for instance, if I have to consider this curve and I want to find out this shaded area, in order to get the area bounded by the curve and the x-axis, you have to integrate the equation of the curve, and after integrating you have to put the boundaries on the x-axis of 5 and 2, and so in order to get the area, it will be integration of x square with the boundaries of 5 and 2. Okay. Now, in order to get the volume of revolution, if you notice, if the same um, um, area is rotated 360 degrees about the x-axis, you will get a solid of revolution, and the volume of this solid is going to be the volume of revolution. Now, in order to get the volume of this solid, we have a method, and that is, if you want to find out the volume of revolution, if the curve is rotated 360 about the x-axis, you will have to square the value of y, whatever, make y the subject, square it, and after squaring it you have to put pi before it. Okay, that means you will have to square y, whatever is the equation of y, square it. Okay, and after that you have to put the boundaries of 5 and 2 here. Also you have to multiply this function by pi. So if you want, you can put pi here, or since it's a constant, you can even put it outside. This is the method of finding out the volume of revolution. Okay, let's start applying it on the questions. Okay, the question says find the volume obtained when the shaded region is rotated through 360 about the x-axis. You want to, right now the area is shown to you, but if this area is rotated 360 degrees about the x-axis, you will notice that a volume solid will be obtained, and you have to find out the volume of that solid. Okay, now what is the method? The method is to square the function. Right now the subject is y, so simply have to square the function. So I am going to write 81 upon 3x plus 2 the whole square. I have already squared it. I have to multiply it with pi. Generally you can keep pi here, but generally what I do is I keep pi outside. Okay, and I put the boundaries of 2 and 1. Okay, so I am going to now integrate this equation. Simply, in order to integrate it, since I have not started with the integration process right now, I am just shifting this whole bracket up in the numerator. So, I am still going to put the integration sign. Okay. Now, from this point onwards, I am going to start with the integration process. So, it will become 81, pi still outside, or what I can actually do is I can shift this 81 outside with the pi. Okay. And since we have done, if you look at the previous videos, if you have a constant, you can always take it outside and then integrate the thing. So, if I start integrating this, I will get 3x plus 2 minus 1 plus minus 2 plus 1 is a minus 1 upon minus 1, and then integrating this bracket is going to give me a 3. Sorry, differentiating the bracket is going to give me a 3, so I have to divide it by 3. Now, this is the result of the integration. I have to apply the boundaries of 2 and 1 on this. Okay, so 81 pi is still outside. I am going to simplify this first. This will become negative 1 upon 3, 3x plus 2 to the power of 1, and now I have to apply the boundaries. 81 pi still remains outside. Minus 1, 3 into 6 plus 2 is 8, minus, and this is going to be a minus 1 upon 3, 3 plus 2 is a 5. Solving this, 81 pi negative 1 upon 24 plus 1 upon 35, 1 upon 15, 81 pi here, 24 and 15. I just have to simply calculate it and multiply it by 81 pi, and that will become the answer. I am just simply calculating it, negative 1 upon 24 plus 1 upon 15. Okay, this is giving me a 1 upon 40. Writing down the final answer now, 81 upon 40 pi. This is the final volume of revolution when the object is rotated, when the shaded area is rotated 360 degrees about the x-axis. Okay, now if we have to find out the volume when the shaded area is rotated 360 degrees about the y-axis. In that case, since you have to apply the boundaries of the y-axis, which are 5 and 2 in this particular case, in that case you have to make x the subject and then square it and then apply the boundaries and multiply it by pi. I'm just writing down the equation here. You have to make, right now you've got y the subject, so make x the subject. Square root of both the sides is going to give you x equals to square root of y. Now you have to square it, so x square is going to be y, so you have to integrate y. Okay, now here the boundaries which you are applying is 5 and 2, and the value of pi will stay here. I am repeating the process. What you have to do is, since in this question y is the subject, so you make x the subject, and then square it, because in the previous example we had to make y the subject and then square the function. Here in this example you have to make x the subject and then square it. When I made x the subject, it was square root of y, so when I square it I get y, so I have to integrate y now, applying the boundaries of the x-axis, which are 5 and 2, and then I have to apply the boundary, multiply the result by pi. Okay, so I am starting with the integration process. Y square upon 2, okay, pi outside, boundaries are 5 and 2. Okay, let me apply the boundaries. 25 upon 2 minus 4 upon 2. Okay, 25 minus 4 is 21 upon 2 pi. This is the answer. The answer will be in unit cube. Whatever is the unit, just have to cube it, since this is the volume. Okay, in this case also I should put unit cube. Okay, the next question is, find the volume of the solid formed when the shaded region is rotated through 360 degrees about the x-axis. You want to find out the volume. Now since this whole thing is not shaded, first of all what you have to do is get the volume. This shaded area is between the curve and the line, and you're noticing that the curve is above the line. So what we are going to do is simply make y the subject from here. Okay, and if I make y the subject here, y square equals to 9 minus 2x square. I'll get 9 minus 2x square. Okay, now make now I'm going to integrate it. 9 minus 2x square dot dx, applying the boundaries of obviously 2 and a 0 here, since this is 2 and this is 0. Boundaries of 2 and 0 and a pi outside. This way I will get this whole volume. Okay, so I'll get the whole, when this whole area, not the specific area, the whole area is rotated, and then I'm going to subtract the volume of this cylinder, which will be formed when you rotate this unshaded area about the x-axis. So you will get, when this unshaded area is rotated about the x-axis, you will get a cylinder. So you have to, from the whole volume you will have to subtract the area volume of the cylinder. Okay, so I'm starting to get the whole volume first, when this whole area, the shaded plus the unshaded area, is rotated about the x-axis. So that's what I'm finding it out right now. Okay, I'm going to start with the integration process. I'm going to write 9x minus 2x cube upon 3. Okay, pi still stays outside, applying the boundaries of 2 and 0 now on it, since the integration is complete. So this will become 9 times 2 is 18 minus 2 times 8 upon 3. This is the first boundary which I have applied, minus 0, because whenever you have a x here and you apply putting a 0 in this will become 0, this will also become 0. So there is no effect of this. So I am just simply simplifying this, which is going to give me 3 8 times 54 minus 16. 54 minus 16 is 38. 38 upon 3 pi is the volume. Okay. Now if I subtract, as I explained it to you just now, that right now I've got the volume when this whole object is rotated 360 degrees about the x-axis. Now since this part is not shaded, so I don't want this, I don't want the volume when this part is shaded, rotated through the 360 degrees about the x-axis. So I know when this part, this will be rotated through 360, I will get a volume of the cylinder, and volume of the cylinder is pi r square h. So in this case the height of the cylinder is 2, and the radius of the cylinder, since the y coordinate here is 1 and this is a 1 here. That means the radius of the cylinder, because if you are going to rotate this, okay, the cylinder form will have a radius of 1 and it will have a height of 2. It will be like this. Okay, so I'm just erasing it here. Okay, so I'm going to take subtract the volume of the cylinder from this. Okay, volume of required solid equals to total volume minus volume of the cylinder. Volume of cylinder is, we know, pi r square h. Pi, the radius is going to be 1 and the height is going to be 2, so 2 pi. So from this answer I have to subtract this answer. So required volume is going to be 38 upon 3 pi minus 2 pi. Okay, 38 upon 3 minus 2 is giving me 32 upon 3 pi. So the answer is 32 upon 3 pi. There is another way to solve this question which I am dealing with on the next page. The technique which we use when we were learning how to find out the shaded area, okay, area between two curves or area between two graphs, we are going to apply the same here. Since you want to find out the volume obtained when this shaded region, which is actually bounded by the curve and this line, and we notice that the line is curve is on the top and the line is underneath, and the equation of the line is y equals to 1. Okay, as a first step, if you don't want to go through this process of finding out the volume, overall volume, and then volume of the cylinder and subtract the two, what you can actually do is get the volume, see which graph is on the top and which is underneath. So the graph on the top minus the graph on the minus the graph which is underneath, but after squaring or after getting y square, subtract y square of this from y square of this, and then simply apply the boundaries. So I want to get the y square of the curve, which is y square is 9 minus 2x square, and y square of the line is, when you square y here, this will become 1 only, y square equals to 1. Subtract the 2y square. Okay, 9 minus 2x square minus 1, which is actually 8 minus 2x square. Now simply apply the boundaries on this of 2 and 1 and you will get exactly the same answer, but the only thing is that you have to put pi before this. Okay, this is the result of the two y's, the y square of the curve on the graph on the top minus the y square of the graph underneath. Okay, I've got this. Now I'm going to integrate this. It will become 8x minus 2x cube upon 3. Now I have to apply the boundaries on this, putting pi before it, 2 and 1. Okay, 16 minus 2 into 8 upon 3, this is the first bracket, minus 8 minus 2 upon 3. Okay, let's solve this. 16 minus 16 upon 3 minus 8 plus 2 upon 3. 16 minus 8 is 8. Okay, minus 16 plus 2 is minus 14 upon 3. Okay, pi. Okay, let's take out the LCM. 3 8 times is 24 minus 14, which is 10 upon 3 pi. Okay, just hold on for a while. Twenty-four minus 14 is 10 upon 3. Yes, pi. 24 minus 14 is 10 upon 3. 10 upon 3 is 24. 24 minus 14 is 10 upon 3. 10 upon 3 is 10 upon 3. 24 minus 14 is 10 upon 3. Yes, pi. 24 minus 14 is 10 upon 3. Yes, pi. Okay, I made a minor mistake here, and that was I didn't have to apply the boundaries of 2 and 1, I had to apply the boundaries of 2 and 0. So this is a minor mistake here, it's 0 here. So obviously this is going to be fine. So fine. Okay, minus 0 minus 0. Okay, so LCM 316 times is 48 minus 16 here. 48 minus 16 is 32 upon 3 pi. This is the final answer. Okay. Moving on to the next question. It says the diagram shows part of the line 3x plus 8y equals to 24. This is the line. Rotating the shaded region through 360 degrees about the x-axis would give a cone of base radius 3 and a perpendicular height 8. Okay, this is very evident here that if you rotate it 360 about the x-axis, this whole part, okay, what we will get here is a cone. It will become, this hole will be shaded, this is going to become actually a cone. Okay, so that's what they're saying, that if you're going to rotate it 360 degrees about the x-axis, you will get a cone with the radius obviously of 3 and the height of 8. Find the volume of the cone using integration. So, I am using integration to get the volume of the cone, and then in the second part they are asking us to find out the volume of the cone with the help of the formula of the volume of the cone. Okay. Now, first part I have to integrate it, I have to make y the subject as a first step. Okay. Okay. So, 8y equals to negative 3x plus 24. Okay, and then it's going to be y equals to negative 3 upon 8x plus 24 upon 8. Y equals to negative 3 upon 8x plus 3. Y square is going to be this whole thing squared, and negative 3 upon 8x plus 3 the whole square. Now, since I have already found out y square, now I am going to integrate this, writing pi outside, minus 3 upon 8x plus 3, applying the boundaries of 8 and 0, because we are rotating it 360 degrees about the x-axis, so the boundaries will be of the x-axis 8 and 0. Okay, let's start with the integration process. So, I am going to start with the integration process now. So, pi here, negative 3 upon 8x plus 3, 2 plus 1 is 3, divided by 3, and then multiplying, differentiate the bracket and write it here. So, when I differentiate the bracket, I am going to get a minus 3 upon 8 here. Okay, so this is the answer. Okay, so I am getting minus 3 upon 8x plus 3 cube. In the denominator I have got minus 9 upon 8. So, divided by, I can write it like this, divided by minus 9 upon 8, which means multiplying it by negative 3 upon 8 x plus 3 cube multiplied by 8 upon 9. So, I can simply write this 8 upon 9 here, multiplied by negative 8 upon 9 here. Okay. So, minus 8 upon 9 pi, I have taken, since it was a constant I have taken it out, and I have to apply the boundaries now on this bracket. And the boundaries are going to be 8 and 0. Okay. 8 and 0. So, I am applying the boundaries here. Minus 8 upon 9 pi, negative 3 upon 8 times 8 plus 3 minus 0 plus 3 minus 8 upon 9. This is going to become a 0, negative 3, which is 24 upon 9 times pi. Okay, if I get the volume through the of the cone with the formula, let's see what do I get. Okay, we know that the volume of the cone is 1 upon 3 pi r square h. 1 upon 3 pi, radius of the cone would be 3 and the height of the cone would be 8. So 1 upon 3 pi 9 8, 3 1 times 3 3 times 24 pi is the answer. So we must have made some mistake here. Let's just correct our mistake from here. So y equals to negative 3 upon 8 . Okay. Okay, if we instead of doing integration here, if we instead of using this integration process, if I just do simply solve this, expand it and then integrate it, let's see what happens. I am just erasing this part. I am applying the formula a square plus 2ab plus b square. Okay, I am writing 3 minus 3 upon 8x the whole square and pi outside and the boundaries of 8 and 0. When I am going to expand it, I will get 9 minus 2 into 2 into 3 into 3 upon 8x plus 3 upon 8x the whole square. Okay, simplifying it further, 9 minus 18 upon 8x plus 9 upon 64 x square okay. I am going to start with the integration process now after this step. Okay, so this will become 9x minus 18 upon 8 x square upon 2 plus 9 upon 64 x cube upon 3 and I am going to apply the boundaries on this 8 and 0, pi here. This will become pi here, 9x minus 9 upon 8x square plus 3 upon 64 x square x cube, applying the boundaries of 8 and 0 on this. 72 minus 9 upon 8 times 64 plus 3 upon 64 times 64, 8 cube is 512 Okay, if I put the boundary of 0, this will become 0, this will become 0, and this will also become 0. So no use putting those. So I'm just simply solving this. 72 minus 72 plus 64 times 8, 24, yeah. So this is giving me a 24 pi. So I'm getting the same answer, 24 pi. 24 pi. Okay, going on to the next question here. The volume, it says the diagram shows part of the graph y equals to 3x plus 2 upon x. The line y equals to 7 intersects the curve at the point P and Q. Find the coordinates of P and Q. If you want to find out the point of intersection of the curve and the line, obviously you have to solve it simultaneously, since y is the subject already in both of them. So you can use the substitution method and you can equate the two, 3x plus 2 upon x equals to 7, and solve for the point of intersection. Okay, so I'm going to write 3x plus 2 upon x equals to 7. Okay, in order to solve this, I will multiply every single term by x to get rid of this x in the denominator. So I will get a 3x square plus 2 equals to 7x. All the terms on one side, I will get 3x square minus 6x minus x plus 2. Okay, 3x, if I take out as common, x minus 2 here, and minus 1 as common, x minus 2 here. If I solve it, the two brackets, 3x minus 1 and x minus 2 equals to 0. So one answer is x equals to 1 upon 3, and the other answer is x equals to 2. These are the 2 points of intersection. Okay, now I have to find out, since I know that y is 7 on this line, so the y coordinate of both the points are, P is going to be 1 upon 2 comma 7, and Q is going to be it's 1 upon 3 comma 7 and 2 comma 7. These are the 2 points of intersection. Find the volume obtained when the shaded region is rotated through 360 about the x-axis. Now, if this shaded region is rotated 360 degrees about the x-axis, okay, I'm using the second method which I told you. Line is above and the curve is underneath. So line square, the equation of this square minus the equation of this square, but y should be the subject, and then applying the boundaries. So line is on the top, so y equals to 7, so it will be 7 square minus 3x plus 2 upon x the whole square, applying the boundaries of the x coordinate, which are 2 and 1 upon 3, and putting a pi before this. Okay, let's simplify it, and then we're going to start with the integration process. 49 minus, I'm going to open this bracket with the formula a plus b the whole square. So it will become 9x square plus 2 into 3x into 2 upon x. 12 plus 4 upon x square. Okay, when I'm going to open this bracket, I'll get 49 minus 9x square minus 12 minus 4 upon x square. 49 minus 12 is 9 minus 2 is 7, and 4 minus 1 is 3. 37 minus 9x square minus 4x to the power negative 2. Okay, now in the next step after this, I have to start with the integration. So, okay, so if I have to integrate this, I will write 37x minus 9x cube upon 3 minus 4x to the power negative 2 plus 1 is negative 1 upon negative 1. Okay, and I will apply the boundaries of 2 and 1 upon 3 on it after simplification. Okay, so 37x minus 9 upon 3 is 3x cube. Minus into minus is a plus. This negative and this negative will make it positive, plus 4 upon x. Okay, now simply I am applying the boundaries of 2 and 1 upon 3. Okay, when I apply the boundary of 2, it will become 74 minus 3 into 8, because 2 cube is 8, plus 4 upon 2 is 2 only. This is the first bracket. Now the second bracket, 1 upon 3. So 37 upon 3 minus 3 into 1 upon 3 cube plus 4 divided by 1 upon 3, meaning 4 multiplied by 3 upon 1, which is a 12. Okay, simplifying it further, 74 minus 28 plus 2 minus 37 upon 3 minus 3 upon 27, which is 1 upon 9 plus 12. Okay, so I'm simply using the calculator to solve this. 74 minus 24 plus 2 minus 37 upon 3 minus 1 upon 9 plus 12. So I'm getting 449 I'm getting 446 upon 9 pi. Okay, let me just check my steps once again. I had to integrate 7 square minus 3x plus 2 upon x the whole square, 49 minus 9x square. Okay, the minor mistake which I had made here was negative into negative is going to become a positive. So this is going to be a positive sign and this will be a negative sign. Okay, so let me just quickly solve it now. 74 minus 24 plus 2 minus 37 upon 3 plus 1 upon 9 minus 12. Okay. So the answer is 232 upon 9 pi. Fine. Moving on to the next question. It says a diagram shows the curve y equals to square root of 4 minus x and the line x plus 2y equals to 4 that intersect at the points 4, 0 and 0, 2. Find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Okay, about the x-axis. So if you want to rotate it 360 degrees about the x-axis, the curve is on the top and the line is underneath. Okay, so first of all we need to find out the equation of, they've already given us the equation of the line. So this square minus this square. Okay, so y equals to 4 minus x, y square is going to be 4 minus x now. Okay, and the equation of the line is x plus 2y equals to 4. So 2y equals to negative x plus 4, y equals to negative 1 upon 2x plus 2. Okay, if I square this, it will become y square equals to negative 1 upon 2x plus 2 the whole square, which is actually 2 minus half x the whole square, 4 minus minus 2 plus 1 upon 4x square. Minus 2x. Okay, so I've just expanded this. This will become 4 minus 2x plus 1 upon 4x square. Okay, since the curve is on the top and line is underneath, curve is above the line, so the equation of the curve which was 4 minus x square here, 4 minus x and the equation of the line. Okay, so 4 minus x minus this whole thing. When I simplify this, I'm getting I have to apply the boundaries of 4 and 0 obviously. Okay, let me simplify it and then we're going to start with the integration. 4 minus x minus 4 plus 2x minus 1 upon 4x square. Okay, if I simplify this, I'll get x minus 1 upon 4x square. Okay, I'm going to start with the integration process right now. So integration is x square minus 1 upon 4x cube upon 3. Okay, I've done the integration. Now I have to apply the boundaries of 4 and 0 and a pi outside. So pi here, x square minus 1 upon 12 x cube. I have to apply the boundaries of 4 and 0 on this. Pi here, 16 minus 1 upon 12. 4 cube is 64. And if I apply the boundaries of 0, I'll get a 0 and 0 here. So no use doing that. 4 3 times, 4 16 times. 16 minus 16 upon 3. Okay, 16 minus 16 upon 3. Okay, which is coming out to be a 32 upon 3. Pi. Okay, let me just quickly check my working once again. Okay, I made a minor mistake here while I was going through the integration process. X square upon 2. I had to write it 2 here. Okay. Now, just applying the boundaries here. So, this will become 16 upon 2. So, it's 16 upon 2 minus 16 upon 3, which is giving me 8 minus 16 upon 3. It is 8 upon 3 pi. So, this is the correct answer for volume unit cube for the first part. Okay, now the second part, they are saying that if the same solid is rotated, if the same volume is area is rotated 360 degrees about the y axis, what will be the volume? Okay, now for y axis you have to make x the subject in both of them. Okay, so let's do that. I'm just taking the diagram down so that I can work conveniently. Okay. Sorry, I have to take this diagram down. Fine. So if you have to rotate it 360 degrees about the y axis, so the equation for the b part, equation is y equals to 4 minus x. If you want to make x the subject, it will become y square equals to 4 minus x. Okay, squaring both sides will release this of the square root sign. Now shifting x on one side, since you have to make x the subject, x equals to 4 minus y square. X square is going to be 4 minus y square the whole square. Okay, if I open this, I'll get 16 minus 2 into 4 is 8y square plus 54. Okay, now I already have squared this equation. I've made I already have x square of this equation. I have to get the x square of this equation now. the second equation, which is equation is x plus 2y equals to 4. Make x the subject, 4 minus 2y, x square equals to 4 minus 2y the whole square. So it's going to be 16 minus 2 into 4 is 8 into 2 is 16y plus 4y square. Okay, now what we're going to do is simply subtract the two. Which one is, as far as if you're rotating it through x-axis, you have to see which curve is above and which graph is above and which is below. Here also you have to see which one is above, which is below. If you see this, if you rotate it through the y-axis, this is above and this is below. So this minus this. So if I take this minus this, it will be integration of 16 minus 8y square plus y4 minus 16 minus 16y plus 4y square. Boundaries may you have to apply the boundaries of the y-axis, which are 2 and 0, and a pi outside obviously. Okay, dot dy. 16 minus 8y square plus y4 minus 16 plus 16y minus 4y square. Okay, I'm still going through the simplification process. I haven't started with integration yet. So minus 8y square minus 4y square is going to give me minus 8 minus 16 is going to give me if I simplify minus 8y square and minus 4y square, this is going to give me a minus 12y square plus 16y dot dy. Okay. Now I'm going to start with the integration. Y 5 upon 5 minus 12y 3 upon 3 plus 16y square upon 2. Okay, boundaries are 2 and 0 and pi here. 3 1 times, 3 4 times, 2 1 times, 2 8 times. So I have to apply the boundaries on 4y cube plus 8y square, and the boundaries are 2 and 0. Okay, so 2 to the power of 5 is 32 upon 5 minus 4, 2 to the power cube is 8 plus 8, 2 to the power square is 4. If I put the boundary of 0, this will become 0 0 and 0, so no use doing that. Simplify this. I'm just solving it. This is 32 upon 5 minus 32 plus 32. This will cancel out. You're left with 32 upon 5 pi unit cube as the final answer, which is correct. Okay, unit cube here. Okay, this brings us to the end of the video. In this class today, we've learned how to find out the volume when the shaded area is rotated about the x-axis or it is rotated about the y-axis. Okay, in the next class of volume of revolution, we're going to do past paper questions and the most recent past paper questions. Thanks a lot for watching the video.